You can run a 10K, feel fantastic, but a blockage is growing inside. How is that possible? Biology doesn't care how fast you run. Your body adapts so well, it can mask a 90% blockage, keeping blood flowing perfectly until it suddenly stops. This is why for half of all men, the first symptom of heart disease isn't pain, it's sudden death. In this video, I'll show you why healthy hearts fail, how your body hides these ticking time bombs, and the only way to check your heart. To understand why a healthy engine fails, we must look inside the heart. The heart muscle demands more oxygen than almost any other tissue. To get that oxygen, it relies on vessels wrapped around it, known as the coronary arteries. Early anatomists thought these vessels looked like a crown, which is where coronary comes from. But I want you to think of them as the root system of a massive tree. If one root is severed, the branch it supports dies almost instantly. We have two main players here, the right coronary artery and the left coronary artery. The left branches into a vessel called the left anterior descending artery, or the LAD. In the ER, we have a grim nickname for this vessel, the Widowmaker. The reason is simple geometry. The LAD supplies blood to the front and bottom of the heart's main pumping chamber. If you block a small twig, you lose a leaf. If you block the trunk, the whole tree falls. A blockage here stops the heart's ability to pump blood, causing massive tissue death. But how does a blockage form in someone who exercises daily? To understand this, we examine the vessel wall. A healthy artery is flexible, like a brand new rubber garden hose. The inside lining is called the tunica intima. In a perfect world, this lining is smooth like Teflon. Blood cells slide past it without friction. But life is not perfect. Over decades, factors like high blood pressure, sugar, and smoking act like sandpaper. Even the mechanical stress of high blood flow during intense exercise can cause microscopic tears. Your body tries to repair these by sending cholesterol like spackle. Then, the immune system sends white blood cells to inspect the repair. These cells consume cholesterol, turn into foam cells, and harden. This hardened mixture of cholesterol, calcium, and waste is called plaque. This condition is atherosclerosis. Now, here is the misconception that gets people killed. Most people imagine plaque buildup like a clog in a sink. They think the pipe gets narrower until water just stops. They assume they will feel it, with shortness of breath or chest pain as the opening shrinks. That is logical, but biologically incorrect. The human body is incredibly adaptive. As plaque grows, the artery wall stretches outward, preserving the opening for blood flow. This is positive remodeling. It means you can have massive plaque, but the tube remains 100% open. You have normal blood flow and zero symptoms. You can run a 10K and feel fantastic because blood is still getting through. This is why the first symptom of heart disease for 50% of men and 64% of women is sudden death. They feel fine until the very second they don't. So what flips the switch? What turns a silent plaque into a fatal event? It comes down to stability. Imagine plaque is like a blister covered by a thin layer of skin. This is soft plaque filled with inflammatory gunk. If you spike blood pressure or exert yourself extremely, that thin skin can tear. This is a plaque rupture. When plaque ruptures, its contents spill into the bloodstream. The body panics. It sees this as an open wound and sends platelets to clot the blood. This is good if you cut your finger, but very bad inside your heart. In minutes, that clot grows, completely sealing off the artery. It's not the slow plaque buildup that killed the flow. It's the sudden, rapid formation of the clot. It acts like a cork in a wine bottle. Blood flow hits a brick wall. This is a type 1 myocardial infarction. However, there is another scenario affecting athletes. Type 2. Consider Robert, a 50-year-old disciplined runner. Robert has normal cholesterol. While running a race, he doesn't feel chest pain. He just feels weird. His energy drops. He feels lightheaded and nauseous. He thinks he's just dehydrated. At the hospital, doctors find a protein called troponin in his blood. Think of troponin like the liquid inside a glow stick. If the casing is intact, liquid stays inside. But if you snap it, it leaks out. Heart muscle cells are full of troponin. If cells die, they break open and leak into the bloodstream. Robert is having a heart attack, but his arteries don't show a 100% blockage. They show a 50% blockage. So how did he have a heart attack with blood still flowing? This is a supply and demand problem. Sitting on a couch, a 50% blockage is irrelevant. The hose is crimped, but enough water gets through. But when Robert's heart rate spikes to 170, his heart demands a fire hose of blood. The crimped artery can only deliver a garden hose. Demand exceeds supply and muscle suffocates. This is ischemia. In Robert's case, there was atrial fibrillation, AFib. Your heart runs on an electrical grid, creating a coordinated squeeze. In AFib, the top chambers quiver. This chaos messes up the timing. Combine partial blockage with rapid AFib heartbeat, and you create a perfect storm. The heart beats so fast, it doesn't have time to fill, and arteries can't deliver enough oxygen. This highlights the 70% threshold. Generally, you won't feel chest pain until an artery is roughly 70% blocked. Below that, your heart compensates. Above that, you might feel tightness walking upstairs that goes away when you sit. We call this stable angina. It's your body's check engine light. But remember, most heart attacks occur in people with less than 50% blockage because soft plaques are more prone to popping than big, stable ones. So if you can feel it, is there any good news? Your heart has a secret backup system, collateral circulation. Think of arteries as interstates. If a jam persists for years, the heart paves side roads, streets to bypass the blockage. This is why a 70-year-old might survive a heart attack that kills a 40-year-old. The older heart had time to build those detours. In a younger person, the blockage is sudden. The highway shuts down and there's no way around it. One of the best ways to force these vessels to grow? Zone 2 and heat training. Exercise builds the network that buys you time, and time is the only currency that matters. In the ER, we say time is muscle. 20 minutes. Irreversible damage begins. 90 minutes. Heart tissue turns to scar tissue. Scar tissue doesn't pump. To save the muscle, you have to recognize the symptoms. Men usually get the Hollywood heart attack, chest pressure, and arm pain. For women, it's insidious extreme fatigue, shortness of breath, or even intense acid reflux. If you feel a sudden sense of doom, don't ignore it. Fixing the plumbing. If the plumbing fails, cardiologists perform a PCI. They thread a tube through your wrist, find the jam with dye, and inflate a balloon to smash the plaque. Then, they deploy a stent, a metal mesh scaffold that holds the artery open forever. Now let's talk about scans to find hidden culprits, the screening strategy. But the goal is to find the fire before the house burns down. Standard blood work only tells you the ingredients in your blood. It doesn't tell you if they're sticking to the walls. You need better data. CAC score, a 5-minute scan for hardened calcium. A score of 0 is perfect. Over 400 is a ticking time bomb. The next scan is CT angiogram. This sees the soft plaque, the invisible, unstable blisters that haven't hardened yet. This is the ultimate early warning system. A healthy heart attack is almost always a tragedy of ignorance. Control your blood pressure to stop the mechanical tearing of your arteries, manage your blood sugar to prevent inflammation, and keep moving. Don't guess if you're healthy. Use the technology we have and know.